In today's global economy, quality matters. Benjamin Franklin once quipped, "The bitterness of poor quality remains long after the sweetness of low price is forgotten." Quality Matters is here to talk about all things quality. So whether you're looking to improve your business, getting ready for an audit, or dealing with failed inspections, tune in, check us out, then get back to doing work that matters.
Hey everyone, thanks for tuning in again to our Quality Matters podcast. This is Darcy. I'm flying solo this week. Kyle's busy doing his work he does. And we're here to share some more interviews with you from OTC 2019. We hope you enjoy listening to these as much as we enjoy doing them.
Okay, we are again here at OTC 2019, and we are here with Hytorc. And this is kind of a fun interview for me, because what I have found in doing a lot of consultation work and auditing and just seeing different businesses is Hytorc is almost one of those terms that's kind of like Kleenex. Not everything is Kleenex, but if it serves the same purpose, people call it Kleenex because it's just so well known. And I find that all the time with Hytorc. People have Hytorc equipment that does not have the Hytorc name on it. So just kind of a fun interview here for me. So go ahead and introduce yourself. Tell me a little bit about what you do here.
Sure. My name is Eric Junkers. I'm the president of the company, also the son of the original founder, John Junkers.
Oh, amazing.
So very much have Hytorc running through my blood since I was a little child. And my involvement with the company obviously varies, as you can appreciate. I get involved in a lot of the sales strategy work, product development type of efforts, and things of that nature. So, really our effort lately has been focused on the same thing we've been focused on for the last 51 years of our existence since 1968, and that's to optimize industrial bolting. We have a singular focus, which is on development of innovative industrial bolting products and supporting those industrial bolting products, looking to make the bolting world safer, looking to make it more efficient. And that's really what we put our attention on. And I think we're really doing that in a unprecedented fashion today with some of our latest releases. This show highlighted with the recognition of our latest product, the Lithium Series 2, our latest battery-operated unit.
Wow.
So we're pretty excited for all that's going to come from that. And, we're looking forward to our future. We feel it's very strong.
I believe so. Awesome. Go ahead.
Sure. So my name is Kunal Rana, and I am the product manager here at Hytorc, handling the electric tools.
Okay.
So the electric tools, we have a new product, the Lithium Series 2, and that is a next generation product. And as a product manager for electric tools, I put a lot of focus on that product in terms of the planning, the development, and the launch of that product.
Awesome. Now, a lot of folks that listen to the podcast aren't necessarily in the industrial area, so we're talking about bolting solutions. Most people probably just think you just tighten it up, right? And then, maybe get a tire iron on it and just, crank it till it squeaks, but it doesn't always work that way, right? So give me, again, kind of the folks that are listening, a little bit of detail about why this is actually highly valuable to so many industries.
Sure. Our world of industrial bolting is a very critical one. I mean, we're involved in putting together and taking apart very critical pieces of equipment, whether it's turbines or whether it's heat exchangers or valves or pipelines or pieces of heavy equipment or so forth and so on. And, it is not always appreciated, but there is a bit of an art to the bolting world. And really, that's where we come in. We've been focused on this, as I said earlier, for 51 years. Really working to educate the masses on the importance of going about your bolting work in the best way possible, as safely and effectively as possible. And that allowed us to be entirely focused on it. It's an area that a lot of people don't think about, so it's not that uncommon. No. And but we do, and it's been our focus for the entirety of our existence. And I think we've done some pretty good things to take the bolting world forward, make it safer, make it easier, and overall better.
No, I definitely agree. Like I say, it's in the world I work in, it's kind of almost a household name for any bolting solutions, whether or not it is. But that just goes to show, the quality and the recognition of the product. But I didn't know anything about this myself either until about 10 years ago. I started working with, a little more than that, but a gas turbine repair company. So you're mentioning turbines. And so I was very surprised to find out that we had to have our basically these wrenches calibrated. I'm like, what are you talking about? You can't get that calibrated. Well, yeah, it only puts so much torque on it. Had no idea, but you later find out how critical this is, because you can stretch the bolt on it, and if you stretch it too far, it's going to break from the vibrations. You don't stretch it enough, the machine's going to vibrate apart.
That's exactly right.
I saw a little bit of your presentation earlier. Tell me a little bit about the new products y'all got out.
Sure. The new product that's out is the Lithium Series 2 electric torque tool. This is a battery-operated tool, which provides portability and convenience to the user, allowing the user to take the tool to places where other tools cannot reach due to cords and hoses and things of that sort. So that's the benefit of the electric torque tool. This Lithium Series 2 electric torque tool, we've made significant advancements in 3 main areas, and that is the usability, the durability, and the functionality of the tool.
Yeah, I saw a little bit of the presentation. I don't think I've ever seen such a sophisticated drill. I mean, this is just fascinating. And so this has the same functions to where you can set the torque and how much pressure we put on it and everything on there. So that was really interesting. Want to make sure that we get all of your information put in the podcast as well. I always like to hear kind of weird stories that people have run into. So what are maybe some of the kind of craziest mishaps or stories that y'all have seen from folks maybe not using your equipment or not doing things properly?
That's a good question. Let me think about that one for a second. Well, there's a video that we do show at some of the shows, and unfortunately, it's the mishaps that occur if you're not using the bolting equipment properly or in the right manner. Can be quite severe and really unfortunate. I mean, we're talking about serious injuries and things of that nature. So, unfortunately, it's not as lighthearted as because you do see some real things go wrong, and and that's why we take it as seriously as we do, because these are very high power pieces of equipment, and they're absolutely necessary. You need them to tighten up these important pieces of equipment, and if you don't use them properly, you do run the risk of seriously getting injured. And so with the latest technology we're bringing out, we're really taking a lot of those hazards entirely out of the equation, and so that really gets us very fired up, because right now I think people are accepting a certain way of going about your bolting as sort of a necessary evil, when it's really not, and that has to do with this reaction arm, the presence of that hazard. So we're doing a lot of things there that has really enabled us to just improve upon what is. And you see a lot of things go wrong. Honestly, bolting, it's gaining a better appreciation as of recently, and I think we're helping to kind of spur that with regards to the training efforts. We just within the past 5 years actually worked closely with ASME, the American Society of Mechanical Engineers, to develop the first industrial bolting course.
Really?
So
that's interesting.
It's called the QBS course, Qualified Bolting Specialist course, and anybody can take it. We've got a number of ATPs, authorized training providers around the country, around the world even.
Oh, great.
And so that effort is all about educating the masses, spreading awareness on how to safely and effectively use bolting tools, so some of these mishaps don't occur. And so I think it's helped and really contributed to a safer and better workplace.
That's awesome. Hey, guys, I really appreciate it. Thank you much.
All right.
Thank you.
All right, this interview is with Joey from This interview is with Joey from Drone Pro. I was excited that we actually ran into him at the conference because I've emailed him several times, but I haven't actually met with him. And they use their drones. This is one that I do understand, so I was really excited. They use their drones to help inspect pipelines, towers, anywhere that people have a hard time getting to, they can take their drones. And it's not the, little drones that you buy off Amazon or at Walmart. These are some serious drones. He had one on display there, and I think Kyle's going to put a picture of it in the show notes. So this was really cool.
Yeah, so Drone Pro's been in business for about 4 years now. And after I had a quality inspection background, we went into the drone business because during the downturn there was a lot of need for cost-effective inspections and things like that, cost-saving measures. So started this up because it's a very good way to get the assets inspected, quickly and much more safely, and we're able to save the customers lots of money, and it's always good when you're able to do that.
Now, not everyone that listens to the podcast is involved in oil and gas, industrial services. So how does a drone save people money on inspections? What are you inspecting?
Sure, exactly. So take an example of a drilling rig with a derrick. So typically you have a 3-man rope access crew, which is basically rock climbing, hanging from the derrick, doing inspections manually. It's quite labor intensive and slow. So what we do is we get the drone up there and we look at the asset ahead of time, and we can pinpoint areas of concern rather than the rope access guys having to inspect the whole asset. So it, in turn, makes it much more efficient inspection.
So with the drone, you're able to keep people from getting into hazardous situations.
Correct. Yes.
And you're not having to have of course, the manpower and labor and all of the other support services that go along with it.
Exactly.
Now, how do you actually conduct an inspection? I mean, is it just a camera? Like, what do you do?
Sure. So all of our guys are inspectors by trades, trained to be drone pilots. So they go up and do a visual inspection with a 4K camera, usually a high zoom, so we can get in and see, all the different small bolts and tools that go with it. So we utilize that. We also utilize thermal cameras for like flare stacks, so we can see hot spots and whether nozzles are working or not working.
Right.
And we can also do pipeline surveys long distances. So that's something new that we're getting into and getting a lot beyond line of sight. So we're able to not only do a visual inspection, we can do 2D ortho maps, 3D terrain maps. We can look for leaks with vegetation cameras and things like that. So
now, how would that work?
Yeah, so it's a cool little camera it's made for inspecting crops. So this camera, I believe it's called a multispectral camera. And so they go out and use crops, and it'll see stress in the plants before the naked eye can see it.
Really?
Quite some time before that. So
that's amazing.
We use it as right-of-way.
The leaks would start to cause problems
so it
before you realize.
Causes the vegetation to die, and you can see it. And hopefully, if you do have a leak, we're going to be a much smaller cleanup area to do that.
Absolutely.
So,
the sooner you catch it, the better it's going to be.
Exactly.
Wow, fascinating. Now, what are maybe some limitations with where you can and can't take these?
Right, actually. There's certain areas you can't take them. There's zone-classed areas on the assets that we look at sometimes. So
these are what, like federal regulations where you
not
apply?
Federal. Yeah, I mean, in different countries there are, like in the Middle East, where we're trying. It's very difficult to get permits and things like that. So here in the United States, it's not too difficult. They've made the process much easier, but mostly almost anywhere else overseas, it's quite difficult to do that. So there's a lot of federal and aviation regulations that go there.
Okay. One thing I always wonder with these is how long does the battery last?
Yeah, sure. That's a great question. So it just depends. So the one we're looking at here, with the setup that we have, it's 20 to 22 minutes. Most of our drones are somewhere around that, up to 30 minutes. We do have the long-range drones that can fly up to 8 hours. So
really,
I mean, it's a huge difference.
These would be for the pipeline inspections.
Yes, exactly. So they take off with electric motors, and then they flip over to their pusher-puller motors, which are gasoline or heavy jet fuel.
Really?
And that allows them to obviously fly longer than just on battery power.
Okay.
No Tesla stuff here.
Now, do you ever do anything where they're like tethered for power or?
Yeah, so there are some instances if you're doing like surveillance on a security deal, which we don't do a whole lot of, but we're trying to get in on some of it. But that would be a great idea to have a tether on there for power going all the time. So
okay, well, it sounds like a lot of the problems from when I first started hearing about this technology about maybe 5-6 years ago, when it's still very, very early. It sounds like a lot of the kind of kinks have been worked out.
It's amazing how far in the last 4 years. I mean, I used to be a lot of fine tuning and a lot of this drone right here. It's a little bit older and it's just lots of pieces and parts, but a lot of stuff's integrated now and makes it much easier to transport. Instead of 3 Pelican cases, we got 1 Pelican case, and the batteries are more efficient. They're safer, and the way they build stuff now. So,
all right. Hey, I appreciate it. Thank you very much.
No, thank you.
Okay, this interview is with a company I believe is called Mesabi. I don't know. Everybody has different names and different things. I don't know. I don't fully understand. Anyways, this company is Mesabi, and we stopped to talk to them about their LM Radiator, which I understand is a frac cube, but I don't understand what that is. So hopefully y'all understand what it is, and you enjoy this interview with them.
We're headquartered in Hibbing, Minnesota.
Okay.
Which is just northwest of Duluth, Minnesota, by about an hour's drive.
Okay.
And it's right on the Mesabi iron ore range.
Okay.
And that's how the company got its start, was building radiators, rugged radiators, for the bulldozers in the mine, for the haul trucks, for the excavators.
Okay.
Because conventional radiators would break down and leak and overheat.
Right.
And an interesting story about this concept of the removable tubes. You know where that comes from?
No.
That actually comes out of World War II. The Brits and their tanks, they were tired of their tanks being put out of action because somebody shot a rifle bullet through the radiator. So they wanted radiators that the soldiers could jump out of, repair, and get back in and go back into battle.
Oh, very cool.
That's how that came about.
Very cool.
After the war, they didn't need it anymore.
Right.
So Rolls-Royce, the car company, started using it. Well, as the car companies became more competitive, that type of radiator was a little too heavy, a little too expensive.
That makes sense.
Okay. So L&M Radiator brought the technology to the United States in 1953.
Oh, wow.
And that's how we started using it for the mining industry. Hence the name, the Mesabi.
Right. Gotcha.
Trade name. Well, as time went on, we realized that there were other applications. And we also realized that the old original concept needed upgrading, updating constantly. So we are constantly upgrading materials in the seals, materials of the tube, manufacturing styles. And I guess it was the mid-1970s is when we first started manufacturing radiators for offshore.
Okay.
For the offshore jackup rigs and submersibles. But what we found out is that our standard copper tube...
Oh, no. Yeah.
It wasn't so bad for the copper.
Oh, really?
But the way we get the gilling, the fins, to stay on the flattened tube, we take a round tube and flatten it, and we have to put gilling on there.
Right.
At that time, it was soldered. There was a little solder film, and the two were almost like being glued together.
Yeah.
But going offshore, after sometimes only months, sometimes it might be a couple of years, the salt air and salt water would erode the solder.
Okay.
And the fins would fall apart, and then you just have a bare tube, and it would be no good.
Right. Then it was good.
That took a couple of years for us to learn that. Then we decided, well, we got to protect that solder from the salt air.
Right.
So we coated it with an epoxy coating.
Ah, okay.
That worked and gave us a couple of more years of service life, but the epoxy coating would abrade away from the airflow. That's what brought us in about 2006 or 7 to develop a brass tube made of Admiralty brass.
Okay.
Think of ship's bells.
Right.
Admiralty brass, and we braze the gilling to the tube. So there's no more solder.
Yeah.
And that's what we're doing now with aluminum.
Okay.
So we're learning that brazing works better than solder in most cases.
Now, we were off mic, and you were telling me a little bit, because when we walked up, I've never seen a cooling system like this. I wasn't even sure what we were looking at first. I saw the fan on the inside. But we've got a lot of bolts on here that look like just a regular socket set at home could take apart.
Pretty much, yes.
So, and that's by design.
Yes. It's for field serviceability.
I love it.
When the guys are out in the field, they typically will have it's just a standard set of sockets. These are 9/16 for what that's worth.
Yeah.
They can pull this apart, take the tubes out with a very simple set of hand tools.
I can see.
Put a new tube and new seals in. Put that back together, and off they go.
Oh yeah, so there's very, very, very little downtime if there's a problem.
It's minimal downtime.
Yeah.
That's correct.
You showed me earlier on the inside. Darcy's going around getting some pictures, so we'll get some good content to go with this.
Very good.
But you can just wash it out from the inside, very, very easy.
That's what it's designed to do, and again, that's for the benefit of the end user customer. That might be Baker Hughes, CUD Services, could be anybody who's running them. Service time, keeping that when that machine's not running, it's not making money.
Oh yeah.
And that's expensive.
Well, I used to work in the gas turbine world, and it's amazing how much money some of these machines make per hour.
Isn't it?
Some of these power generation companies, this is not what this used for. Just an example for people listening, is they lose over $1 million an hour when some of these turbines are down. And same thing in the field. If you've got a rig that's producing and it goes down for cooling issues, you don't need to take a lot of downtime to get it fixed. But unfortunately, I've seen some of the ways that it operates. There's a lot of downtime with these repairs. I mean, we've got full-time maintenance crews working around their clock to keep stuff up and running. You hardly would even need a maintenance crew for this.
Just about right. And the whole idea is that somebody like me can go out there. And when I say somebody like me, I'm not a mechanic.
Right.
But I can't tell you how many of these I've gone out in the field with a customer to show their crew how to do it. And I've done complete radiator changeovers along with their crews. Anybody can do it if they want to.
Yeah.
You know.
Well, and you were saying too, and I absolutely see it looking here. You said that if one of these rolls over, which stuff happens for all sorts of weird reasons.
Oh yeah.
That you can replace the entire side panel. And
Correct.
you don't have to worry about the rest of it.
That's correct.
So,
Yes.
Very, very neat, very innovative solution on such an old technology.
Isn't that? That's right. Yeah.
It is.
And this will outlast. This radiator system will probably outlast the service life of the equipment that it's mounted on.
That's awesome. So just this is what I'm loving about OTC is we're seeing so many interesting ways that technology that people never think about that impacts us all over the place, and just so many ways that we can make it better. We can make it safer. I mean, for this alone, we're not having to worry about high power tools. We're not having to worry about heavy equipment. It's something that literally one or two people could do all the work on. And so it decreases the options for incidents, increases uptime. So it's wonderful. I love it.
You're exactly right. It increases uptime.
Yes.
Keeps that equipment in service.
Absolutely.
You
Thank you
bet.
very much.
Hey, thanks for talking to me.
Thank you.
Okay, this interview was with a lady from the NASA Technology Transfer Program, which was really interesting. I didn't even know this existed. Neither one of us knew it existed. We just went to talk to it because it was about NASA, and guess what? Kyle was geeked up about it. So we went over there to talk to them. And so what NASA believes is that they develop technology that's not only good for NASA, it can be good for real-world problems. So they have several, I can't even remember, hundreds or thousands of patents. And there's a website you can go to and look at them all. And if you think it fits a project you're working on, you can contact the site that it's at and talk to them about getting a hold of that patent. And she talks in the interview about what some of their technology has been used for. And I think they release a book about it every year. So this one was really interesting to talk to and for y'all to listen to, I hope. And maybe even go check out the website. And Kyle says he's pretty certain some of that technology might be incorporated into Texas Quality Assurance over the next year.
All right, again, last day of OTC 2019, and had no idea, but NASA is here, but technically the NASA Technology Transfer. We're here with Jordan. Mm-hmm. Why is NASA here at OTC?
Yeah, so a lot of people don't realize that NASA technology is being used in your everyday life, and it is our job to kind of bridge the gap between companies and all the amazing technologies that NASA develops in-house. Today we're here specifically because we have a lot of materials, coatings, sensors, water purification processes, stuff like that would be really beneficial to the oil and gas industry.
That's awesome.
And you gave us pamphlets that people can go check out your patents.
We did, yeah. If you check out nasatechnology.gov, you can view our entire
list of patents.
It's okay. It's been a long week.
Our entire patent portfolio. All in all, I think we have about 1,400 different patents available to be licensed out.
That's a lot.
Cool.
Yeah.
That's a lot.
And then you also shared their software, free software.
All of our software can be viewed at software.nasa.gov. We have about 996 codes available to be used today. We upload new codes daily.
I have a feeling you might be seeing some of this integrated into version 5 of our software.
Okay.
Yeah. There's all kinds of good stuff out there, stuff in project management, system testing, stuff in environmental science, propulsion, aeronautics.
Very cool. Now, so if someone wants to use the code or the patents for the materials, what do they have to do to be allowed to use this?
So for the software, if you look, each individual code will have a different label with it. Mm-hmm. Some of it is open source, some of it is general public release, some of it is U.S. citizens only, some of it's government use only. It just kind of depends case by case.
Sure. Okay, well that makes a little bit of sense. How about for the patents for you're talking about materials? How's that work?
So there are each individual NASA center is in charge of what they develop in-house at that center. So basically, if you find one of these technologies online and you're interested, on the last page there's a little bit of contact information for that specific center, and the licensing manager will set you down for a free consultation with the inventor. You guys can kind of talk about it, see if it's a good fit for what you're trying to use it for.
Okay.
And if so, then they'll go through and negotiate the terms of the license.
It's pretty cool.
That sounds cool.
That's pretty cool.
So I'm really interested in the spin-off that you showed us. You said you'll have a book every year. I guess people can purchase that.
No, actually, it's completely free.
Oh, wow.
We send a lot of hard copies out to universities and stuff like that, but the entire book can be viewed online at spinoff.nasa.gov. We produce one every year showcasing 50 different companies who have used our technologies in the past. One thing that I am really proud of this year is there is a technology that was developed for the Apollo program that was used inside of our spacesuits, and it's now being used on stadium roofs. And it is pound for pound stronger than steel, but it's super lightweight, and it actually allows light to pass through it, so you can grow real grass on the stadium floor.
That is
so
really cool
to me.
Love
what
it.
was the purpose of light being able to pass through on the space, or that was just something that happened?
A happy accident, I believe.
That's great.
I like it. And you were saying that memory foam was a NASA development?
Yeah, so memory foam was actually developed over at Ames Research Center, I believe. And they were trying to figure out a way to add padding to airplane chairs to counteract like vibrations and stuff. That's why when you see the commercial for Tempur-Pedic mattresses where there's a wine glass on one side and they're jumping and the wine glass is not tipping over, it's because it was specifically designed for that.
Oh, that's very
interesting.
cool.
Yeah.
Interesting.
And then you said something about baby formula. I'm interested. We had 3 kids. They were all formula babies.
Yeah.
So how did that come about?
So baby formula actually came about because we were researching work with algae as a way to provide a food supplement for astronauts on long-duration missions. Not only were we trying to use it as a food supplement, but as a way to eat their waste and produce oxygen.
Oh.
And as we were working with this algae, we found out that it contained some of these enzymes that were prominently found in breast milk. And these enzymes were crucial for visual and mental development. And so now it can be found in about 99% of formulas out there.
Oh, wow.
So how long ago was that found and put into baby formula?
I'm not sure of the exact year.
I'm just curious if formula was already around and this was added in, or this helped to develop baby formula.
I actually don't know that one. I'm sorry.
I'm sorry.
Don't worry about
That's a hard question.
Don't worry about it. So how long has this program been going on? Because I've never heard of it before.
So I believe it started in 1985.
Oh,
it's
really?
actually a requirement for all federal laboratories to not let our technologies die behind closed doors, but to actually push them out into the public.
Really?
Neat.
Very interesting. Well, I know that I am going to be taking a look for sure, not trying to promote our business, but we have a software that we've developed for quality management. We're always looking for ways to integrate project management and testing applications. So, I can see immediately how they'd be used for us. And I can only imagine how many other folks out there with a small business anxious for some new ideas and new technology to bring into it, that this could be a wonderful, wonderful tool.
Yeah, we'll take some pictures and put these addresses on the show notes.
Absolutely, absolutely. Any last comments or questions before we close out?
Yeah, just that NASA technology is just being found in your everyday life. It's not always just useful for up there, but it can also be useful down here on Earth.
Awesome. Thank you very much.
All right, now we have an interview with Matt from Lark Heat Treatment, I believe. This is one Kyle finally drew me in to interview with them, and I had absolutely no clue what they were talking about. I think actually during the interview I said, I don't even know what question to ask you to help me understand. But Kyle was totally geeked out talking to these guys. He loved it, and I think he actually has an appointment to just go check out their facility because it's something that he likes to do. So these guys are super cool. If you have a need for this service, contact them. They're friendly guys. I don't know what they do, but hopefully you do.
Okay, so just start from where you were going, and it'll get recorded in.
Okay. My name is Matt Clark. I'm the third generation with my family with Lark heat treating. My grandfather, my father, and my uncle started the company in 1978. Started with about $5,000 and 5,000 square feet and have grown ever since then to the beginnings of one furnace, one quench tank, one temper, and my grandmother operating a drill press to now where we are, 60-something furnaces operating, one of the largest heat treat facilities in the South, one of the largest vacuum facilities in the country, south of Solderton, Pennsylvania.
Wow.
And I'm a little biased because my last name's Clark. So
that I just find so fascinating. So that this has been, the third generation.
Yes, sir.
To run the family. I love it. Or run the business. I love it. I absolutely love it. I say all the time that's one of my goals for our business, that someday I'll get to see my grandkids
be able to pass it on. Absolutely.
Yeah, that would be fantastic.
So for people that don't understand what you do, like myself, tell us about what y'all do.
So Lark is a commercial heat treat provider, and we have a number of different operations where either we can soften up metal for the large forgings where you want to machine something out of it. It makes it easier for the machine shops. We can harden up the material once you've got it completed for downhole tool applications. Case hardening, either carburizing or nitriding, which is adding a very hard case to the outside of the material. Okay. We have induction hardening, which is doing basically the same process but doing it through electricity, adding that hard case to the outside of it. What am I missing, Calvin? So open fire, atmosphere, vacuum, nitride, vacuum furnaces. There you go. Sorry.
And that's where I've got a little bit of experience with the vacuum side.
Exactly. So a lot of your air hardening tool steels is where the easiest way to start that would be. Some of your material you heat it up to a temperature and you have to drop it into a quench to get it to harden. Some of your tool steels and some of your stainlesses will harden just through air. So what we do is run it up to that temperature in a vacuum and then actually use a gas quench, argon, nitrogen, and that will force it to cool off a lot quicker. So instead of going through the quench phase like in a water or an oil or a polymer quench, that forced gas will cause it to harden up, then go through the temper process. And when you do that in vacuum, you can have a finished material, actual finished part. You send it to us, we'll harden it up. You're not going to have any scaling, and it's actually going to come back to you prettier than when you send it to us.
Right. Well, yeah. Because what I found when I did this before is that, just quenching it in a liquid of some sort, even quenching it just in ambient air, there's still other molecules and materials in the air that can sometimes come into the metal, which is why you say what you have is it actually comes out prettier than when you put it
Correct.
in. Because there's nothing to interact with the metal. And that was just one of the most fun things for me. I know we had one customer that the official requirement was that all of his parts come back shiny. So we had a special heat treat and we had a special way of buffing the parts so that his parts came back shiny.
Funny enough, we actually have a customer, and obviously I can't tell you who it is.
No.
Right.
We'll run it through the vacuum, and they come out just looking beautiful, perfect. Well, when they're done, they have to go through a temper process. This customer specifically wanted them vacuum hardened but air tempered because they wanted it to discolor a little bit.
Really?
Their inspectors would look at it and say, well, it comes back shiny. They don't know it's been heat treated. So,
oh my gosh.
Wow.
So
wow.
it's changing the outlook and having everyone understand that it doesn't have to be scaled up in order for it to look like it's been heat treated.
Right.
And that's where some of the education comes in, teaching people that, you have to be able to check the hardness to see where it's at.
Yeah. Well, now, how large? Y'all got a really large furnace. How large is y'all's largest furnace?
Open fire, we have one furnace that's 12 foot across, 10 foot tall, and 22 foot in length. For one of our customers, we've run 155,000 pounds in it at one time. And that's our largest open fire. I think as far as nitriding, we have one that's 44-inch OD, 72 inches vertical. We have a 72-inch OD, 96-inch vacuum furnace that we've purchased, unfortunately, it's still sitting in Canada. We're dealing with Harris County to try to get the building permits. We've been fighting with them for about 2 years.
Oh, wow.
It's not fun.
Yeah, once we get that done, then we'll have that one and another 2 bottom load vacuums that we've purchased, get those online.
Wow, that's amazing. That's amazing.
Well, I hope that people understand what he's saying, because I think I'm more confused now than when you started, and I don't even know what questions to ask to understand it.
Well, I'm not going to pretend to be the expert on this, but basically it's, the softer the metal is, the more you can work with it, but then it tends to bend and deform and deflect. The harder it gets, of course, the less it's going to bend and deform and deflect, but then the more likely it is to crack or the more brittle it gets.
Correct.
And so these guys put, when I say put science, it is like true science behind how do we get this material for its composition to give you the properties you're wanting.
Okay.
And one of the things that my grandfather used to always say is it's half science, half art. So we still have to be able to look at the chemistry of the material and say, maybe this one has a little too much carbon, it has too much vanadium, it has too much moly in it. So we really need to be careful about it because it's a high hardenability material. If you quench it too fast, if you don't get into the temper quick enough,
right,
it'll be so hard it becomes brittle, then that's where you start having some
well, and I guess
cracking
that's
issues.
what Kyle was trying to explain to me the other day, why this is better after we left talking to you, and he was saying that I guess if you don't have this available, you use heat blankets, and it kind of heats unevenly and not all at the same time.
That's a stress relief process. So a lot of times what'll come in is you have 2 pieces of metal, obviously you have to weld them to join them together. Mm-hmm. So people will send us that to go through a post-weld heat treat or a stress relief. So it's just exactly what it says, is to take the stresses out of the material. Mm-hmm. You can do that with a blanket process, and there's a lot of really good vendors out there that do that. But what we do is put the entire part into a furnace and heat it up below the tempering temperature to take those stresses out of the material. Nothing wrong with those localized stress relief guys. A lot of the stuff that they will work on sometimes is even bigger than the large furnace that we have availability for. Sometimes you're dealing with 60, 80, 120 foot long pipe.
So maybe that's the only option.
Correct.
Well, anything to add before we close up?
No, just thank you guys for coming by, giving me the opportunity, and anybody listening, stop by and see us. Lark Heat Treating, 6640 Maynard.
Absolutely.
Yeah, they're right here in Houston.
Yeah. Hey, one quick question before we go, and I try to ask this people. Everyone's got some kind of crazy story of something that went wrong, things that weren't planned for. You got any fun stories about maybe folks that had things go in the furnace that might not have gone in the furnace?
Not so much that direction. The funnest one is we do have some vertical pits. Mm-hmm. So when they have an ID in the material, once it hits the quench tank, it's at 1600 degrees and it hits the oil. Well, oil is combustible. So when those parts start dropping down that quench tank, it almost becomes a flamethrower. So there's a flame curtain that hangs underneath the crane. So obviously we always warn our customers when they come in, if we're quenching a vertical load,
right,
get ready for it.
Right.
And we had a customer that said, oh yeah, I've been in a heat treat shop before, yeah. So they came out, saw it quench, and when they did, they had a personal accident.
Oh,
I love the way you worded that.
That's probably that's probably the closest I can come to a funny story that's happened at the shop.
Oh, that's awesome. All right. I appreciate it. Thank you.
Absolutely. Thank you, guys.